Hello and welcome to my talk about polyglot environments leads to polyglot security holes. My name is Sven Ruppert and I'm developer advocate for JFrog, and right now you can see that I'm sitting here in a forest in the middle of Germany. Slowly the summer is going away, but it's a perfect time because nobody else is in the forest anymore and you can really sitting down there relaxing and looking for wild animals. So far, what we want to do today, we want to have a look at the typical environment we are coding right now and what does it mean in terms of security. If you're interested in this, stay tuned. Polyglot environments and why this is leading to way more security issues. Let's have a look at the state of art, what's going on today in the field of development. So more and more projects are organized in the structure of a cloud native app. What does it mean? Cloud native is structured in different layers if you're reading a little bit about it. So like service-oriented architecture, API-based communication, and containerized infrastructure. And everything is organized by the term DevSecOps. So what does it mean? They are explicitly talking about DevSecOps. Why? Why not pure DevOps? If you're looking at the pure DevOps part, you will see that the DevOps part that's coming from the history, let's say during the last 10 years or so, is mostly focusing on the topic to structure the way the project is organized between the dev people and the ops people. And if you're looking at the plain structure or steps that are mentioned, you would see that's mostly describing the development process itself and the deployment on the infrastructure or the deployment somewhere, so that's running in production. In this term, DevOps, you're missing the part security. Why security? Security is something that is more and more important because more and more applications are not just one monolith, they are not just one application behind a firewall. It's a zoo of different microservices and so on. So if we are looking at this cloud native stack, it's sure that we are dividing the system in more and more tiny tools. And the question is why? We are doing it because we can see that if we are splitting up the big use case we want to implement into smaller ones, then we can implement every tiny part independently, concurrently to the other one, so we can speed up the development process. We can try different technologies and single components, and everything is more or less wrapped in containers like Docker and then orchestrated by Kubernetes. Every tiny part should be independent in terms of persistence, in terms of technology, runtime environment, and so on, so that every team will have the freedom to decide what's the right tool for this tiny part of the big application you're implementing. If you have the freedom to choose between the technologies freely, and you can, for every microservice, using a different environment, a different tool stack, different languages to implement, then you have several things that are working against you. So it's working against you if you're always coding in different languages. Why? Because if you're working for 10 years in one programming language, then it's most likely that you really understood the language all the time, that you know what are the bugs, what are the good points, what are the best practices, and so on. If you are just new in a language, you can transform some knowledge you have already into the new system. You can say, okay, the best practice in terms of design pattern, in terms of whatever. But you have to learn mostly new toolings, and you have to relearn, or you have to transform design patterns you already know into the syntactical environment of the new language. New languages mean that you have different behaviors in terms of CPU utilization, in terms of memory management, in terms of how to persist data, and so on. But if you have this more or less under control, the next layer would be that you are orchestrating everything, and then you have this part communication layer, or this is this part of how to serialize data and pushing it to the next node so that you can use it. For this you have this API oriented layers. It's fine because then it's neutral in terms of technology. But on the other side, if you're looking, for example, at the Java stack, you will see that a lot of security issues or vulnerabilities are in the field of serialization. So exactly this, what you need to communicate with all the other tools or microservices, is one of the weak points of this programming language. Maybe it's different in different languages, but you have to make sure that for every language you know what are the weak points. But talking a little bit about the security stuff now. So if I know that I'm dealing every time with new technologies, then I have always to learn from scratch how to deal with common security issues. For sure, it's always the same if you say don't use plain text passwords, for example. So this is a common practice. It's neutral in terms of language, but on the other side, what's with this serialization, what's with this mapping of data, what's with I/O operations, and so on. So security is something that is not only given by the architecture itself, like using plain passwords. It's not only given by the firewall that surrounds this stuff. It's not only given by the language itself. It's mostly really driven by dependencies. So dependencies means that for every language you have a different type of repository. Different repositories mean that you have other way around. So if you start implementing whatever language or tool you're using, then you have the possibility to use already existing stuff. Let's have a look at this cloud native stack. For example, the application is coded in Java, then the corresponding repository would be a Maven repository. The next layer would be Linux. So in Linux you have maybe Debian, and then you are just dealing with Debian repositories to maintain the dependencies here. The next one would be Docker. If you're writing your first Docker file, the first line would be a from statement. So you're again dealing with repositories and dependencies. And inside the Kubernetes world, you have this Helm chart if you're just reusing complete stacks. If you're looking at this one, it would be perfect if you can manage all these repositories in one point. And this is done, for example, by Artifactory. So you can have this one single logical point. And if you have this logical point to manage dependencies, then you have one point where you can start grabbing the low-hanging fruits for security. So DevSecOps means, in short words, that the part security is everywhere. In every single step you're thinking about security. Security is something that is like quality, like performance. It should be present from the first line of code you're writing. And then if you're looking just at this stack, and we have all these dependencies, and we know that all systems are mostly composed by dependencies, then managing dependencies and scanning dependencies is one of the really low-hanging fruits if you want to start dealing with security. So you have different layers of security. For example, you can check what code you are writing. You can start scanning your code against bad practices, patterns, and so on. But if this is just 20 or 30% of your code and the rest are just dependencies over all layers, it makes way more sense to check dependencies instead of start looking at your own code. That is, as I mentioned, a really low-hanging fruit. So for this, we are offering, for example, Xray, because with Xray you can scan all dependencies in Artifactory, and this means that if you have a vulnerability in one of the binaries, and you have the view over all repositories and repository types, and you understood every repository over the time, means that you have the full impact graph of the vulnerabilities that are available via dependency inside your application. But why this polyglot thing leads to polyglot security issues? If we decompose the full application, and I'm just looking at one single microservice, and I want to start with my first proof of concept. I'm just creating a fresh new POM XML if I'm using Java and this is managed by Maven. Then I would start adding the first dependency because I want to try something, maybe how to generate a PDF, how to sort, I have some string utilities, whatever. And that means that in the moment I'm adding the first dependency here, it would be good to know immediately what are the security issues on this or inside this dependency I'm adding, and if there is another version without these vulnerabilities. Because if I'm doing it right now after adding the dependency, means that I'm not burning money. The other way would be I start writing my proof of concept. I'm integrating my proof of concept into the CI environment of my company, and then the first CI run would detect this vulnerability and would say, okay, here's something you have to deal with. And then you would start rewriting it, changing the dependency, or searching for an equivalent algorithm or whatever. But then you have invested already a lot of time. So it makes sense to have exactly this one immediately after adding the dependency, so that you right now from this point of time you could start thinking about, okay, get rid of this one, changing dependency or whatever. Okay. But if you're just working with one tiny microservice and you're just in this layer, before I'm going to this polyglot world, what I mentioned is, if you're doing it from the first line of code inside your coding, then this vulnerability is not existing in all other layers anymore. So if you're rotating this layer from application to Linux to Docker to Kubernetes and rotating this picture a little bit to the left, then you see where this term shift left is coming from, if the application is the first thing you're doing before you're mapping all this stuff in Docker and then ramping up in Kubernetes. But if you're looking at these layers and you see if there's a vulnerability in one of the first layers, then it will be present in all other layers as well, active or inactively. But in the end, if you're looking from the Kubernetes layer to the whole stack, then all vulnerabilities in all layers are the full possible composition of security attack vectors. So, and this means that you should minimize as early as possible. As early as possible means that the highest priority should be eliminating security or vulnerabilities inside your application in this coding phase already. So if you're checking these dependencies, you have to trust other people, and this must be checked by a machine, not by a human. So that's it. Okay, having this one, then the next thing is why the laziness or the comfort is exponentially growing the amount of vulnerabilities even inside an application. So if I know that the most vulnerabilities are, or the critical or the lowest hanging fruit of removing vulnerabilities so that they are not existing in different layers is during the time I'm coding, I have a special eye on this one. So now I want to focus on an example that shows you how the convenience on the one side is leading to more security holes on the other side. And for this we want to have a short overview about, for example, web components. want to explain a little bit what I mean with web components. Just as a short recap, assume that you are a server-side developer, that you have to write this web UI for your microservice. It's for internal usage maybe, or whatever, so a tiny one, but you're a server-side developer, and mostly you have to deal with REST APIs and this mapping and so on, and you have no clue about, for example, graphical web UIs. And then you start searching and oh damn, then you found something, for example this open source stick that will give you the possibility to use web components, and this standard is nice because you can start composing with existing web components, something that's running in nearly every browser, and so many components are already existing. And then the first step is, okay, before I start learning HTML, CSS and JavaScript and all this stuff, I can just use this web component, and with this web component I have a standard now, a standard that is supported by nearly every browser so far these days, and then I can build my web UI for this. But I'm not really interested in all this tech stack that is on the client side. So the first would be, what are the web components? It looks like it's a standard based on HTML5, CSS, JavaScript. Then you have this component. It will lead to a dedicated HTML tag. And this tag can be used just in a plain HTML site. That looks great. And then you start searching for how to get these web components. Oh my god, it means I have to deal with NPM. Okay, the next technology. So I'm just creating the next NPM repository in Artifactory, say Xray, please scan this one. I make my NPM install to grab some web components. I'm adding the first import statement to an HTML file, HTML page and so on. But it's not really convenient. And it shows you that this NPM stack is just really a pain in terms of security, because you're adding this NPM stack and it's just, oh my god, so many red flags. And then you saw, oh, there is an open source tool that has a generic API, and this will give you the possibility to use its web components like a plain core Java class. What I'm talking here, I don't want to go into this detail how to map this one. It's really easy. So I have on YouTube some videos about how to map web components on the Java side with a generic API of Vardin Flow. So if you are interested in this in more detail, so the technical part, check out this one. There's a video about how to map individual web components, or how to mix them up with different existing ones, or how to write JUnit 5 tests against it. But let's assume you have the possibility now to map these web components to a Java class. And now the convenience is just the winner. So you, as the guy in the team that has to maintain this stuff, will say, oh, I found a way to have a button like a new button. So like in Swing, like in JavaFX. If you want to have a button on your web page, then you're just writing new button, and then magically you have something. What does it mean? This tech layer is now responsible for several things. So you have this web component on the client side that is dealing with JavaScript and all this stuff. The next thing, you have this communication layer that's offered by the Vardin Flow open source library. And then you have this Java dependencies on the server side, plus your own dependencies you have. But what you have now several stacks. And if you're giving this one to your colleagues, immediately what they are seeing is, oh, I have a jar, I can use this as a dependency as I know it. And then I'm just adding this dependency, I'm writing new button, setting text, adding click listener, whatever, and then I'm done. So the people will be just happy, because this way of convenience is exactly what they're searching for, because normally they are server-side microservice developer. But on the other side, you have to make sure that immediately you will provide all the security infos that are available about the Java dependencies, plus the full NPM stack, and the same about compliance. So far I'm just talking about security in terms of there's a possibility to hack your system. But security could be understood in a way that you are securing your business as well. So not only against attacks or whatever. It means you should have an eye on vulnerabilities as well as on compliance issues. And then you need exactly a tool that is helping you, for example Xray, that is able to scan not only for known vulnerabilities, but is able to scan for compliance issues as well. And in the end, what we see, or what we are doing here is, we understood now that with more and more convenience, we're adding more and more tech layers, sometimes in a way that is a little bit sneaky, because your colleagues are not really seeing the full stack, but you have completely different environments, different behavior, different life cycles, and so on. So leading or technology that's leading to convenience and helping you to produce faster and easily, this is just awesome and should be used. But on the same time, be aware of the fact that new technologies and the whole composition of this tech stack is a beast in terms of security. So really check them constantly right now from the first line of code. If you want to try out how this feeling is, at JFrog we have this free tier that you can just activate. I have a YouTube video in my YouTube channel, and then I show you how to activate a free tier. What you could do, or what I really would recommend, so that you try it out once, is you creating, for example, an application, adding this in a Docker file, and for this you are creating the repositories inside Artifactory, activating Xray for these repositories, and just checking what known vulnerabilities are even in these tiny projects you can do in 15 minutes, whatever, with a few dependencies. Check it out by yourself. It's really good to see what is there and what are the layers that are infected. I have a few YouTube videos about how to use, for example, this JFrog plugin inside your IDE, so that you see immediately the vulnerabilities from your dependencies. It's available for the free tier as well. So just activate the free tier, connect with the JFrog plugin to this one from your IDE, and scan your existing projects just to have a first overview, and you will see that you're even there at this point. You will have enough stuff to do and enough possibilities to harden your system. An example how this is done from the workflow is on YouTube in a video called How to Harden the Vaadin Flow Framework, and in this video I will show you more or less the following workflow. You're scanning for these dependencies. You will get the dependency information as well as the transitive dependency information, and then you start excluding even transitive dependencies with vulnerabilities and declaring them explicitly with new version numbers if there's a fix already available. And then what is very important, test coverage. Test coverage is really, really important, because if you have a good test coverage, then you are able to change dependencies immediately, the versions, even major versions, and you can verify if the application is still running and will deliver the same behavior that you are expecting. So quality and security, they're going just hand in hand, and this is in every single layer. For example, if you are dealing with predefined Docker images and they have maybe Debian as a basic, then what you could do is you're using this Docker image, you're scanning this one. If there is some vulnerability in this layer, just push this Docker image in your own Docker repository and extend it in a way that you're just doing some maintenance commands like update or upgrade, so that you are updating unsecure or outdated libraries from these predefined Docker images, scanning them, and if everything is okay, just use this one as well. This can be automated because Xray is able to is providing all features via REST API, and if something is detected, it can activate some webhooks, and with this you can integrate in third-party components like reporting system, auditing system, dynamic workflows, and so on. Yeah. So what I want to say in general is we have with this cloud native environment the possibility to split up huge applications in tiny chunks. This is perfect. Every tiny chunk could be implemented in some kind of technology, but you need a tool that will help you to give a coherent view over all used technologies and the full impact graph, so that you know what vulnerabilities and compliance issues are important or critical for your system that you are using. Convenience means that you are faster in terms of development, but you have to deal with more used or hidden used technologies. For example, with this web component, you're using just your Java new button, but in the end, you are dealing with NPM and web components in the background as well. So I have this in mind, and this is why I'm saying polyglot environments are nice, but polyglot environments leads to polyglot security issues. If you want to hear more about stuff like this, just check out my YouTube channel. Otherwise, I'm very happy that you attend my talk, and I would say stay safe, and I see you.